Okay, so let's address something that I referenced earlier in an earlier video, and that's procedural programming and object-oriented programming. Procedural programming talks about like a set of operations that are executed in a sequence. So it's a sequencing style of algorithm, and we take each one of those algorithms and we put it into a procedure, and those procedures are broken into logical units. To understand procedures, we need to kind of understand variables. A variable is a named computer memory location that holds values. So the idea is we carve out a part of memory, like a little box, and we name that little box some name. And in the case of procedures, we're actually naming the procedure, and that procedure like holds all the statements that we're using for that. So it puts that into memory, and then when we call that particular procedure, it allows us to call those individual steps. So imagine like we want to have a ball bounce or an object bounce in the world. You might have a bouncing procedure, and anytime any ball needs to bounce, it will call that procedure, and it would be utilized in that way. That's the idea of procedure-based programming. It's native to the language. The way we think in English, when I tell somebody to clean their room or go pick up your textbook, or accelerate your car. There's a lot of steps involved in that we don't directly talk about. The procedure calls all of those steps to the process. Another kind of programming is something called object-oriented programming. In object-oriented programming, we create a class which is a blueprint for an object. The blueprint will have attributes and behaviors. So speaking back to that ball, in procedural programming we would call like a bounce method that maybe a variety of things might use. In an object-oriented programming, we create like a ball class. And the ball class has all the attributes of the ball, and it has the functions that the ball might have, so like the bounce and the throw or whatever a ball might do. Every ball we create will hold its own attributes and its own like behaviors, and it'll work from there. When we have this blueprint, then we can create objects from that blueprint. Object-oriented programming allows us to create applications, and it was really developed originally for simulations. So it's a very powerful idea, and it's kind of the way we think in the world. So when I think of an object, we think about what an object does and what an object has. And those questions, like what does a car do? How can we define a car? What is a cow? How do we define a cow? Those things make our brains think in object orientation. Object-oriented programming was most frequently used for two major types of applications: computer simulations and graphical user interfaces. Not all object-oriented programs, why can't I say that today? Not all object-oriented programs are written to use a GUI. We may make an object-oriented programming for a game, like even on the screen, or maybe we're just doing file input and output using an object to do so, and we're not using the GUI. But object-oriented programming is useful when building a graphical user interface. Object-oriented programming differs from traditional procedural programming in that we have polymorphism, inheritance, and encapsulation. I'm going to spend more time on that in later videos, but just be aware that with polymorphism I can change an object. So I can have like a master class that I can change. For example, I can say canine, and a canine can be a dog, a wolf, or a coyote, but it's the children of the canine are inheriting attributes and behaviors. Inheritance means I'm borrowing, like all canines will have fur, so I can inherit that particular method. Another idea that we talk about in object-oriented programming is called encapsulation. The idea is that I wrap a lot of data in this object, but only show a little bit of data to the user, so I'm hiding a lot of information. Encapsulation is similar to a concept known as abstraction as well. Those things don't happen in procedural programming. I'm going to stop the recording here.